All right, we're on page 671. This is lesson 12.4. This is similarity in right triangles. Whenever you guys see this right here, oftentimes I tell you guys to go ahead and I want you guys to see this particular triangle, and if you observe this particular triangle, you actually notice that there are actually 3 triangles in this single object that you guys see in this shape. So what I want you guys to do is this. I want you guys to get used to writing the 3 triangles in the same direction. And the reason why this is important is because you want to go ahead and observe which sides correspond to each other. Since the triangles are in fact similar, then you guys could go ahead and write a proportion for each of these triangles. So the first triangle that we see here, we notice that this is 90 degrees. This is 90 degrees. I'll go ahead and take the most obvious one, which is this one here. S, Q, and this will be P. Alright, but if this is a right triangle, we know that this is also going to be a right because it's triangle sum theorem. This has to be a 90 degrees as well. Alright, so we have this one here, but we'll wait for this one here. Let's take the bigger one here. Alright, well, if we take the big one here, we notice that P here is in fact the right angle. And then since Q and Q are the same, I could go ahead and put Q over here. And this has to be R. We're good? Now, if I take a look at this, we know that this right here is a 90 degrees, so the S has to be over here, correct? Well, if we know that this is R, and then this is R, I'll go ahead and put R over here and P over here. I repeat again. If we know that this is angle R and this is angle R, angle R and angle R has to be congruent because they have not changed. And this has to be R as well. So if we were to write this here and look at this triangle, I could say triangle PQR. What does that sign mean? It's similar to what triangle over here?
R space.
Well, if I said PQR, this one has to be what?
SPR.
SPR. Is similar to what triangle over here?
SQP.
SQP. So this is the correct way of writing it, because now we can go ahead and do proportions on it. If we have sides that are given, then we could go ahead and use this statement here to answer any given information. So we're going to do the same steps, but we're going to actually use specific numbers on this particular type of triangle. So if we take a look at this triangle over here, alright, the very first thing, like I said, I'll draw it out. And let's go ahead and label it. Let's say this is A, B, C. Let's call this point D. What is the most obvious triangle that you guys see here? We'll start off with ABC. Alright? We'll start off with the most obvious one. Do not write any numbers inside, for the segments yet, the size of the triangle. Just leave it alone. Let's just go ahead and put this so we know triangle ABC is going to be similar to another triangle. Well, let's take this one over here. We know that this here is another right triangle, right? Well, this angle here, this point has to be what, guys? D. So we'll start off with D here. So let's take a notice this. What does this triangle here have in common with this one here on these two sides? I mean these angles over here. A, right? So A should be up here, guys. And this one should be what? B over here. Why? Because A has to be the same thing as angle A, correct? So we'll start off with that. So we could say the next one, triangle what? ADB. If we say ABC, it has to be ADB.
Oh,
We'll do the third one now.
should have been dab.
Right? So we know that this is 90 degrees here, right? This has to be D over here. Which of the two should I write first? This side or this side, and why?
B, because we already have it written on the other chart.
But remember, the most accurate one is what? C. Because B is actually cut, right? We do know C. C is perfect, so C should be going where? Here. C should be right over here, guys. And B should be right over here. You guys see it? So this right here should be what? Triangle B, D, C. Now I could go ahead and write the information inside these three triangles. Now that we have it perfect, why? Because we know C is congruent to C. We know A is congruent to A. So we could go ahead and write it down. AB is what? 65. AB here is also what? 65. It doesn't change. Correct? AD is what?
25.
This is AD here. 25. And that's it. We do know what DB is now, though. How can we figure out DB? Pythagorean theorem. So let's use Pythagorean theorem. Here we go. This will be 25 squared plus, what is it?
60.
B squared.
B squared is equal to? Let me work it out, guys. What's 25 squared?
625.
625 plus B squared is equal to what?
4,200.
4,000.
Oh, I heard 1,200.
Can't hear you, I'm sorry.
4,005.
4225?
25.
How do we solve for B?
Subtract 625.
Subtract 625 to both sides.
3,600.
B squared is equal to 3,600.
You answer 60.
And then you square it and use 60.
So that's one of the first questions we know. Well, y is actually 60. Y is what?
60.
dB is 60. I could go ahead and put dB over here is 60. Correct? We're looking for this side here. We need to know DC over here. What else can we do?
Right.
Yeah.
Which one?
The line segment thing. Oh, wait, no, never mind. That doesn't work. But,
Mm-hmm.
Oh wait, no, right question between like this. Use the second triangle to figure out
You could use a second triangle here to figure out what?
the other triangle, but like the side. Because you only have one.
So how do you figure out Z or X?
Pick one.
Tell me which one you want.
Either.
Alright, let's figure out.
Oh, that's right. That's why it's quiet. That's why it's so quiet, yeah.
he said it's not me.
No, it's always not. Yeah.
It just helps with it.
Exactly. I'm confused. Can we just write a proportion?
You want this one here? AC.
Sure. Yeah.
So what's AC, guys?
I don't know.
25.
X plus 25. Very good.
I knew that.
Yeah, you do that.
So if it's X plus 25, and then what else do we know? BC is what? Z. What's DC? X. What's BC? Z.
So let's find BC.
Mr. Kuzin's confused.
What do we do next?
You look right proportion. So do I.
You can write a proportion.
Essentially.
Tell me the proportion. We could use this right here, guys.
Yeah.
So this will be what? 25 over 65 is equal to what?
60.
60 over
70.
Z.
Oh shit.
Z. And the reason why is why? Because these two are what? Similar triangles. If they're similar triangles, we can go ahead and write a proportion. So cross multiply these two numbers and divide. What do we get?
156.
156.
So Z is equal to what?
156.
So Z is here is 156. We could do two things here to solve for X.
We can do the Pythagorean.
We could do the Pythagorean theorem or what else?
Just the Pythagorean.
Or
Love
no.
science.
Or proportion.
Oh.
Yeah.
So
But like, you know Pythagorean?
if we use these two here, we could use these two here. This would be what? 25 over 60 is equal to 60 over X.
Why must you do that? The Pythagorean theorem is like so much easier.
This is much easier.
No, it is not.
It's equal to 144.
Z is equal to
12
X is equal to 144.
X. Sorry.
No one cares.
Wait, no, wait. Now X plus
Pythagorean
25
theorem is you just
give us
square it.
AC.
So what's AC?
AC is
169, which is 13 squared.
And we're done.
yeah, it is.